Lesson 37, Analyzing Data for Two Dependent Samples. Example 2. Do Sierra College elementary statistics students work more hours in a typical week on average than they study? Conduct a hypothesis testing procedure using a 0.05 level of significance and the Sierra College Elementary Statistics Student Survey to answer this question statistically. So in this example, we'll conduct a hypothesis testing procedure using the customary alpha equal 0.05 level of significance. In order to answer the question, do Sierra College elementary statistics students work more hours in a typical week on average than they study? So in the Sierra College Elementary Statistics Student Survey, question 9 asked how many hours do they work in a typical week, and question 8 asked how many hours do they study in a typical week. Since we had one population of students from which one sample was selected, but two data values were collected from each of the students, this data involves two dependent samples. So the difference is calculated and analyzed using one population inferential statistics methods. Here, the difference of the first data value minus the second data value occurs when question 9, the hours worked, is the first data value, subtract the question 8, the hours studied, which is the second data value. So these differences between question 9 and question 8, the hours worked and hours studied, can be entered into the TI-84 calculator. To do this, we would press Stat and Enter to enter the list editor. I'll enter the differences into list 1 by arrowing up to list 1, and then selecting question 9 by going second Stat, and arrow to the cursors next to Q9 and press Enter. And then subtract to find the difference of question 8, which is found by going second Stat, arrow up to the cursor to Q8, press Enter to select. Now list 1 will contain the differences between question 9 and question 8. So now that we have the data entered into list 1, we can continue with our problem. Now here the question is, do the students work more hours in a typical week on average than they study? So if they work more hours, we're taking a larger data value and subtracting a smaller data value, thus resulting in a positive difference. Positive differences are values that are greater than 0. So here in the test, when we're looking at this on average, we'll be conducting a test where mu, the mean difference, is greater than 0. So we'll be conducting a hypothesis testing procedure for just one population, mean. So we'll follow the following steps in order to conduct our hypothesis testing procedure, starting with stating the hypotheses statistically. So here in the question, we're looking at the mu difference between the hours worked and hours studied is greater than 0 when the students do work more hours on average in a typical week than they study. But if that's not the case, then we'll get the opposite result, which is that mu, the mean difference, is less than or equal to 0. So the less than or equal contains the condition of equality, so that's always labeled as the HO. And the opposite, without the equality, is labeled as the H1. So here the statistical form of the hypothesis in this test is HO, that mu is less than or equal to 0, versus H1, that mu is greater than 0. In this case, HO would lead to the answer of no, students do not work more hours in a typical week on average than they study. And H1 would lead to the conclusion of yes, students do work more hours in a typical week on average than they study. Now that we've stated the hypotheses, we then select alpha, the level of significance. In this test, we're using the customary alpha equals 0.05. Next, we can use the t-test command on the TI-84 calculator to calculate the p-value needed to reach our decision. So we already have the data entered into list 1. So we can press Stat to do statistics, arrow over to the tests menu, and then arrow down to t-test. Press enter. For input, we have the data. mu0 is the actual number in the hypothesis, which is 0. The list of data where we entered the differences in was L1. Freak is 1 because each data value came from one student. H1 has the greater than inequality, so I arrow over to the greater than and press enter to select, and then down arrow to calculate. Enter gives us our results of the t-test. Now, the result that we need to make our decision is the p-value, and that's the one that says p equals. Here, rounding off the p-value to 3 places after the decimal, we find that the p-value is approximately 0.035. So now that we have our p-value, we can make our decision. Since the p-value of 0.035 is 0.05 or less, the decision is to reject HO. And whenever we reject HO, that means we have sufficient sample evidence to indicate that HO is not valid. And if HO is not valid, the opposite idea, H1, is the one that is valid. In this case, the mu greater than 0 indicates that, yes, on average, the students work more hours in a typical week than they study. So, based on our results of our hypothesis testing procedure, we can reach the following conclusion. Therefore, at the 0.05 level of significance, Sierra College elementary statistics students do work more hours in a typical week on average than they study.